So we're in the future, it's 2021, and this is a story about Sam. When he felt ill and went to the hospital, the doctor told him diagnosing him is expensive as it relies on using sensors based on silicon photonics. Sam didn't have covered medical insurance, so he thought he might die. But suddenly the nurse jumps in with wonderful news. UBC students finally found a way to develop silicon photonic technology at a low and affordable cost. Sam, being an electrical engineer, is astonished. Now, not everyone here is Sam, so let me tell you what silicon photonics is, why it's expensive, and the reason behind Sam's astonishment. Inside our everyday tech devices, such as phones and tablets, you can find tiny chips made of silicon. Silicon photonics is the technology that uses faster photons instead of slower electrons to transmit information on these silicon chips. Now, besides being faster, light has the unique feature of interacting with the surrounding matter, like our blood, for instance. What does that mean? Well, early detection of diseases such as cancer can be at our fingertips. Sounds promising, right? So where's the culprit? It is this tiny device, a laser. It's a device that generates light on the silicon chip. Once we attach lasers to silicon chips, some devices on the silicon chip act as tiny mirrors, reflecting light back into the laser. This renders an unstable laser, making it emit light of multiple colors and eventually halting its operation. So aren't we smart enough to solve this problem? Well, 60 years ago, researchers developed a device known as an optical isolator, which diverges any rays going back into the laser. But the way that's done is neither environment nor economic friendly. They use earth elements, which are extremely rare, making it a very expensive solution. And actually, there isn't any alternative cost-effective solution yet, and that's the reason behind Sam's astonishment. In my research, I solved this problem without using rare earth elements. How? I designed an optical circuit on silicon platform that uses the exact same concept behind your noise cancellation headphones. I exploit the wave nature of light, and I create a wave that destructively interferes with any light going back into the laser. That renders a stable laser, making it emit light only at a single color. This solution is very promising because it's made on silicon, which is the most abundant material on Earth. In fact, it made it the most cost-effective solution to date, and it can finally enable us to integrate lasers inside our everyday tech devices. And for patients like Sam, it can finally enable him to early diagnose himself. And who knows what else? Perhaps imagine poor families in developing countries finally getting connected through faster technology, but at a much lower and affordable cost. Thanks.